Morning. I think this is morning. I'm not sure. Welcome to 2022. This is January 4th of 2022. Amazing that we're into another year, and it is going to be. We're going to kickstart this year with some good events, great events. I think we got some. Today we're going to have it's a Tech Tuesday. I think we're going to have to start calling these Tech Tuesdays, because at noon today, at 12 o'clock p.m. Eastern, you need to check out the IAEI's YouTube site, where we will be talking about the time. We're going to continue our discussion on the time current characteristic curve, the TCC curve. We will continue to build out our little power distribution system. We're going to do a refresher on the TCC curves, on what they're telling us, and we're going to talk a little bit about damage curves, because we're going to take a look at the conductor damage curves. We're going to take a look at transformer damage curves, and how the overcurrent protected device relates to those time current characteristic curves and what they tell us. So we're going to hit TCCs. We're going to continue our discussion on the time current characteristic curve through practical applications. We're going to correct some of our, in our power system, I think last week, I've got to review my conductor sizes. So we're going to have to take a look at the, from a power distribution system, our ampacity calculations that we used. So we're going to continue that discussion. And then at 5 o'clock p.m. Eastern today on my channel, I'm going to hit, I want to start a series on power systems design. What started me on this discussion point was what we're doing over there on IAEI with regard to the time current characteristic curves, creating that little one-line diagram. I think 2023 code cycle is behind us now. We're going into our annual meeting and whatnot. So all the voting is pretty much behind us. And now we need to start thinking about other things and how we want to apply the National Electrical Code to power distribution system design. And the NEC has a place for design. We got to, when we're laying out a new building, a new structure, a new application, obviously we have to keep the National Electrical Code requirements in our vision, but we have to think about the customer's wants and needs and what they're going to need in regard to their power distribution system. So I want to take a look at power systems with an eye on how we lay out systems. What are the key decision points? It says something as simple as voltage. What voltage do you have for your structure? Do you bring in 480 volts? Do you bring in 208 volts from the utility? What are the determining factors on why you pick the voltage levels that you pick for the design that you're going to implement? So I want to review and have a discussion around those key decision points. What size service do we need? We know a lot of that's driven off of load calculations. So we'll get into load calculations as well. I got my Keith Laughlin thinking pen, and we will use that this afternoon. So this afternoon at 5 o'clock p.m. Eastern, on my channel, on my YouTube channel, and my LinkedIn and Facebook channels, we will start our journey on power systems design. On the IAEI's YouTube channel, we are going to probably finish off our discussions on the TCC curve. I don't know. It depends on how far we get and how we. is less than 4,000. So how we and see how that discussion point progresses. So in any case, that's going to be our discussions today. I hope you are going to kickstart your 2022 with a technical discussion and join me. I would hope that you will join me in both of those forums. So, and if you have any questions, or if you have any areas that you would like to see explored from a technical perspective on our program here, please send me an email. ThomasADimitrovich@eaton.com. Or check out my YouTube site or my website, thomasdimitrovich.com. www.thomasdimitrovich.com. And we will have a technical discussion around whatever topics that you think we need to explore. All right, so that's today. Tamaki Ono, Happy New Year. Thank you. Happy New Year. Hope all is good with you, Tamaki, in Japan. And looks like we made it through another year. Man, it's amazing, isn't it? Time flies. And it is January 4th already. I did a blackout. I just stepped away from the computer, the phone, everything. And I tell you what, it was well needed. But I'm ready to get started again, Tamaki. So think about some things. We're going to do a medium voltage focus this year. I want to start talking about medium voltage applications. The National Electrical Code has made some changes around medium voltage. I think we need to understand where the code is going, but just in general, medium voltage equipment installation and selection are all important topics that hopefully all of you will find of interest. So that's sort of the lineup today. 12 o'clock Eastern, IAI, we're going to continue our TCC discussion. 5 o'clock Eastern, we're going to get into power systems design. So hopefully you will be able to join me 2 times today. And this week, also Friday, I'm going to do a Q&A Friday. We're going to pick up on our Q&A Friday. So if you have questions on any types of questions and things like that, that'll be Friday session, 12 o'clock Eastern. And maybe Thursday. We'll do another Tech Thursday to continue our power systems design discussion. I've already picked out some of my reference books. Can't go anywhere without my Industrial Power Systems Design by Donald Beeman. This book is dated 1955, but I'm telling you, it is still a great reference because the laws of physics do not cease to change. So that is one key reference we'll be using in our power systems design. And this is really more so, I believe this is more utility aspects. So this might be more medium voltage, but it's Electric Power Distribution System Engineering by Turan Gonan. That's another good reference. So I'll be getting out some of my reference materials for our discussions, our technical discussions on power systems design. Obviously, the red book, the buff book is going to be in there. Maybe the industrial book, the gray book from IEEE. I don't know. I might have to open up the library and see what other types of references that we'll need to have a good discussion around power systems design. All right, and obviously the National Electrical Code 2020 NEC is the reference that I'll be using. Okay, everybody. Well, listen. How about today's topic? Is the damage curve a topic that is something to do with the induction motor? Ooh. So the damage curves, now there are motor damage curves as well. They're very, very rarely do I ever see a motor damage curve plotted. I guess I can tell you why. What I typically see, Tamaki, is a motor starting curve plotted. So when you get down to the loads, especially like in like a motor load, we'll plot the motor starting curve, and then we put our overcurrent protective devices as close to that starting curve as we can, obviously without tripping the overcurrent device, to give it maximum protection. Now there are motor relays that will take in a lot of other data points like temperature. The very large motors will take temperature RTDs that may be built into the motor. There might be overspeed, over frequency, and other things like negative sequence frequencies and whatnot for motor protection. So the more expensive the motor, the more intricate the relay, and typically those parameters are determined based upon manufacturer specifications to say, look, you shouldn't say, for example, it's a negative sequence. You'll be looking for a certain percentage of negative sequence based upon manufacturer's information and some application guides. But for the most part, on motors, we plot the start curve, and that tells us that the inrush currents, the asymmetrical inrush current, the inrush current, and then the transition over to the full load amps. The damage curves that I'm thinking about are the damage curves related to conductors, which are they're typically just a straight line, and that's like the melting for the insulation damage, really on a conductor. That's what you're looking at. For the most part, for the high short circuit protection, for the small conductors, we always worry about the vaporization of the copper, right? You have an annealing point, which is the point at which the copper gets like flexible enough that you'll get a loosening of your connections. So you don't want current to flow too long where it's annealed and whatnot. But for the most part, the damage curves, the thermal damage curves, are for the insulation on a conductor. And I think a lot of people forget about that. And I've seen that. I've had that in discussions, where you start talking about, like, say, protection of the equipment grounding conductor is not necessarily. Most equipment grounding conductors are bare copper conductors, and you're not worried about an insulation damage, thermal insulation damage, because unless your bare copper conductor is right next to your thermoplastic or your insulated conductors, but you're more worried about the annealing point, which are very high temperatures, the annealing point, or the can't remember what they call it. When copper basically vaporizes. So from a high short circuit currents and whatnot. So, but from a conductor perspective, we'll plot the conductor damage curve and the transformer damage curves, which we talked a little bit about last week. And those can be intricate. The smaller transformer, anytime you get something that is less expensive or just smaller in your electrical power distribution systems, you don't have as much information as you have on the large equipment, the very expensive equipment. So, hey, Nihad. Hey, I did see your note, Nihad. I will be looking at that today and get back with you. Sorry about the blackout there. I got tied up in a basement here working on some things, and I we'll be talking probably. I'll communicate with you sometime today. So, but the damage, we'll be talking damage curves from a conductor, damage curves from a transformer perspective, and how the percent impedance. So we'll give you some of those references that you can use to read up a little bit more on transformer damage curves as well as conductor damage curves. So I want to talk. So that's the IAEI's focus. But what started me for my session, and maybe we'll continue our discussion on the IAEI site, but we're going to explore in a more free-flowing manner on my channel the power systems design perspectives. So and before we purchase anything, we're putting it on paper. We're laying out a one-line diagram. We're trying to figure out what size equipment, how much equipment, how many breakers we need. We're going to have to figure out what size service that we need, what voltages that we need, things of that nature. So the types of grounding that we will be using for an industrial or a commercial power. I'd like to focus a little bit more on a commercial building perspective. But that's sort of our afternoon, and that'll be our Tuesday 5 o'clock and our Thursday at 5 o'clock sessions. For some reason, my Keith Laughlin pen is clicking, and it's not supposed to click. Oh, I think it's this. I don't know. There we go. Fixed it. Okay, so that's going to be our program today. Ireland, Mr. Ireland is in the house. Thanks for joining us. I was just going over what we were going to do, so hopefully I helped you, Tamaki. You're welcome. And our friends from Ireland. So 12 o'clock, IAEI News Live. You got to check that YouTube site out. Subscribe to it. We need more subscribers. Got to get them people. Got to click the. I just need some people just to say, hey, click the subscribe. Set the bell so you know when we go live. I think that's going to be an important part too. So in any case, it's 7:59. I want to make sure I get off of here by 8 o'clock because I got to get stuff. I got a lot to do today. So we will see all of you at 12 o'clock on the IAEI's YouTube channel. And we're going to continue our discussion on the time current characteristic curves, which will include circuit breaker curves, fuse curves, and their relationship to each other. And also we'll get into conductor damage curves, transformer damage curves, and motor starting curves. Maybe we'll throw a 480 volt motor on there and take a look at that. And I'd love to have the discussion around what, from Tamaki's perspective, the comment about damage curves on a motor. I mean, there are damage curves on a motor, but rarely do we see those plotted. But maybe in our journey on the IAEI's website, maybe I'll grab a motor pro expert from Baldur or whatever. I don't know. We'll grab a motor expert, talk a little bit about motor damage curves. That would be a good discussion. So anyway, look forward to seeing you 2 more times today, the beginning of 2022. I want to wish everybody a happy new year. I hope your holidays were safe and healthy and found yourself with friends and family. And for those that we've lost in 2022 in the electrical industry and anywhere else and all of your families, my condolences. And we got to start and continue 2022 with them in our memories. And make them happy, knowing that we're doing the right things for electrical safety. So, and for the electrical industry. All right, so Mr. Ireland, Happy New Year, brother. Happy 2022. We will see you guys at 12 o'clock today and at 5 o'clock, 2 different channels. And I think that's it. So stay safe, at least until 12 o'clock when I can remind you again, and stay healthy again, at least until 12 o'clock when I can remind you again. Until we meet again online, thanks for joining in. Take care, stay safe, God bless, and please stay healthy. All right, everybody, signing off. Take care.